Hello everybody, how's it going? This is lesson number 3. It's about write a program to display all the prime numbers from 1 to the user number. In the previous course, we take how to check the prime number. We take number from the user and we check if this number prime or not. And in the second lesson of course number 4, the lesson before this lesson, we check if it's perfect number or not, and we also take the first lesson we check if it's perfect number or not, and the second lesson we print all the perfect number. We want now to complete also how to print all the prime numbers, because in the previous course we take just how to check the prime number. We didn't take how to print all the prime numbers between number 1 till the user number. For example, if the user insert number 10, you want to print all the prime numbers from number 1 or between 1 to the user number, which is number 10. Okay, so how we're gonna build this program or solve this problem? First thing, we have enum. We name it en prime or not prime. 1 represent prime, 2 represent not prime. We say enum is represent the numbers with descriptive names. Okay, and after that we have this generic function that you already built it many times and use it many times in our problems in this lesson and before even. We just change its name in this course. Get positive number. It take the question. Let's open it just to remind you how it look like. Same logic, value, do while loop, break statement, and everything. Okay, you already know it. And after that we have another function. We create another function. We name it check prime or not. Check prime or not. It's from user defined data type, which is the name of the enum, and it takes the value. Okay, it takes the value from the previous function. Let's open and see the logic inside it. It's like from the previous problem from previous course. We just change a little bit the logic. First thing, we have if statement. We check if value less than or equal 1. Why we say this? In the condition of if statement, if value, which is number 10. Let's assume that the user insert number 10 and we start insert value. If it's less than or equal 1, print not prime, return not prime. Why? Because 0 and 1, they're not prime numbers. They are not prime numbers. All the negative numbers and 0 and 1, they're not prime numbers. So we check from the beginning. If the user insert 0 or -1 or -2 or even number 1, we return directly not prime number, no need to go to waste our time in for loop. But if the user insert different numbers starting from 2, the compiler will ignore this if statement, not go inside it or check it. Directly will jump, the compiler directly will jump to this for loop. What we have in this for loop, we said integer I equal 2. We assign number 2 to the variable I. Why we assign number 2 to the variable I? Because we say the prime number start from 2. Okay, so here we come into the condition of for loop. 2 less than value. Let's assume, as we said, that value stored inside it number 10. We take it from the user number 10. So 2 less than 10, true, the condition of for loop true. So the compiler will go inside the for loop and face this if statement. What we have inside this if statement? If value mod I equal 0, return not prime. If the value number 10 that we take it from the user through the console screen, we mod it with I variable inside it, number 2. If 10 mod 2 give me 0, return not prime. And after that, get back to the update of the for loop and update the value of variable I by 1. Increase the value of variable I by 1. So I, it will be represent 3 less than 10, for example, I less than value. Yes, for second time, get inside, check if 10, if value mod 3, because value is stored inside it number 10, we take it from the user through the console screen. So if value mod 3, because I already represent inside number 3 because we increase it just right now, equal 0, return not prime. If it's prime, return prime. Here outside, when the compiler finish the for loop process, we'll return all the numbers that they are prime. So this is the logic how we check if it's prime or not prime. And after that, we have this procedure, display prime numbers. It takes the value. Let's open and see the logic inside it. First thing, you have this string prime numbers from 1 to the user number, and we give it the value, which is stored inside number 10 to be between parentheses r. This is a string we just printed before the compiler print for us all the prime numbers. We want the compiler print for us this string first. Okay, and we define integer data type. We declare variable I, also local variable. We name it I here, equal to y starting from 2, because the prime numbers starting from 2, 0 and 1, they are not prime numbers. And we have while statement. While I less than or equal value, I stored inside number what? Number 2. While 2 less than or equal 10, from where we got number 10? From the user through the console screen. When the user insert it, we store it inside variable as code value. Okay, so while 2, because here we assign to it number 2. While 2 less than or equal 10, so the while statement condition will be true. The compiler will go inside the while statement and face this if statement. If check prime or not, we use the previous function and we give it the I, which is number 2, equal prime, see out I. Print this number, because the requirement of this program that we want to print all the prime numbers starting from 1 to the user number, and the user now insert number 10. So we want to print all the prime numbers from 1 to number 10. So here when we come to say if check prime or not, and we give it the I, we let the compiler take the number that's stored inside variable I and go to check prime or not function, which is user-defined function, and check by the logic inside that function, and check if this number prime or not. If this number prime, print prime, see out I, print this number. If it's not prime, then print it complete, increase the I by 1, I plus plus. So I, it will be represent number 3. 3 less than 10, I less than or equal value, true for second time. So go inside the while loop and check number 3 or check the value that's stored inside variable I by using check prime or not function. If it's prime, print it. If it's not prime, go increase the I value by 1. I already represent number 4, 4 less than 10, because value variable stored inside it, number 10 when we take it from the user through the screen when we did run. So after the while statement condition become false, the compiler will exit this while statement. And here in the main function, we just have nested functions. First thing, we call the procedure, this is the last one, display prime numbers. And we put inside its parameter get positive number, the first function. And inside its parameter, the get positive number function, we put this string because we have a variable, it's called question. We don't assign any string to it. It's from string data type. We assign our customers the question here. We already know this. Please insert a positive number. So once we did run, the compiler come here. Please insert a positive number and take the number, store it inside the value variable that we declare it inside the get positive number function. So get positive number function, it will hold for as the value or the number, and we'll take it to display prime number. Display prime number, compiler will go to display prime number procedure, which is this one. Display for us the string first, and after that check if this number prime or not. If this number prime, print it. If it's not prime, increase the I and don't print it. How we will check the number is prime or not? By using or through this function that's called check prime or not function, is user-defined function through this logic that we wrote it inside this function, check prime or not. So that was the problem of today. Problem number 3, write a program to display all the prime numbers from 1 to the user number. I think we didn't run this program, so let's run it together to check how it's look like this program. Perfect. Once we did run the compiler display for our discussion, please insert a positive number. Let's insert number 10. Prime numbers from 1 to the user number. Number 10, perfect. Now me as a user insert number 10 are 2, 3, 5, 7. These are all the prime numbers. If we run it again and we insert bigger number, for example number 50, please insert a positive number. Let's say number 50. Prime numbers from 1 to the user number, which is 50, correct, are 2, 3, 5, 7, 11, 12, 47. All these are prime numbers between 1 and 50. So that was the problem number 3. Write a program to display all the prime numbers from 1 to the user. See you next problem, next lesson.